let's solve today's problem. This problem is from ICPC and its rating is 1800. So as always, we are going to explain this problem by introducing the example here. Alright, so let's take a look at the example. So we are going to have a number of test cases here. So we are going to have 5 test cases. So 1, 2, 3, 4, 5. And we are going to have 5 outputs, right? And for each test case, we are going to have 2 numbers. The first one says the number of different height of people in the following array, right? And there are 3 kinds of people. The people with the height 1 has 3 of them. The actually has 7 of them. The people has height of 2 has 1 of them. The people have a height of 3 has 13 of them, right? And the second number is the number of rows in the array, right? We're going to have 4 rows in the parade, right? So we are going to find is the maximal number of people in the parade, right? And there is one condition we need to satisfy. That is the number of people in one row should be the same, right? Let's say for the first output, we have 4 rows. That means each row has 4 people, right? So the first row has 4 people, second row has 4, third row has 4. The last row also has 4, right? And in a same array, the maximal height difference cannot exceed 1, right? So let's see, for the first array, we can put 4 height 1 people here, right? 1, 1, 1, 1. And for the second array, second row, we can put 1, 1, 1. That is 7 ones. We used up all of those people height with height of 1, right? We still have 1 spot left. That is we can put a height 2 here, right? So we only have 1 height 2, right? And the maximal height difference in this row is still 1. So the condition is satisfied. Okay, so move to the third row. We can put 4 3s here, right? The same as the last row, we can put 4 3s here, right? So that is the maximal number of people we can put in the parade, because we had to make sure that we have 4 rows filled up, right? So how do we solve this problem? So in order to solve this problem, we need to find the maximal length of a row, right? Apparently, because the number of rows is already given by the problem, right? So the only way we can increase the number of total people in this parade is to increase the number of people in one single row, right? Let's say if this row has 5 people in it, that means each row has 5 people, and we are going to have 20 people in this parade. But is that possible? We can try it out, right? Let's say we put 5 people in the first row. We can put 5 ones here, right? And then for the second row, we can't fill up it with the 1 here, right? Because if we put a 1 here, then it means the maximal height in this row is 2, right? So at most we can have 3 people here. We cannot fill up this row. So these 3 people, these 2 people are removed from the parade. We can't fit them in any row, right? So we can still use the second people, the people with height 2, right? So we put the height 2 in the second row and fill up the rest of the space with height 3 people, right? Now, four height 3 people is here, and then fill the third array with more height 3 people, right? That is 5. So we already used up 9 height 3 people, right? And there are still 4 left, right? But these 3 people cannot form a row with 5 people in it. So we cannot satisfy the condition with with 5 people in each row, right? So height the answer of 20 people in the parade is not valid, right? So apparently we need the length of a row as long as possible, and if it gets too long, it won't satisfy the condition, right? So in this case, we are going to use binary search. So let's say the initial setting of the binary search is that we can have the left is we have 0 people in each row, right? The right is the extreme case that we have thousands and thousands of people in the in each row, right? So the upper limit is let's see, what is the upper limit? So because the n's upper limit is 30,000, and this guy is 10 to the 12, 10 to the power of 12, right? So let me see. Okay, so the number of people in a same height is 10 to the power of 12 as well. So the upper limit of the number of people in one row is this guy times this guy, right? So we can set up the upper limit here. So let's take a peek at the code. So this is my upper limit, right, is 10 to the power of 16 multiplied by 3, which is exactly the factor of this guy and this guy, right? So what's next? So let's say we have an upper limit and a lower limit, and we are going to choose the middle point as first choice. If so, this number is going to be the number of people in one row, right? If we can satisfy, if this number satisfies the condition, so, then it means that we can possibly get an even bigger number. So we remove the left part and try the right part. So this is the new lower limit, and this is still the upper limit, right? And we can choose a new midpoint here and check if this number of people in one row satisfy the condition. If not, that means it is too big, right? So we are going to remove the right part and look into the left part, right? And try a smaller number, right? So so in this case, we are going to binary search the number of people in one row. So with the number of people in one row is setted, that means we can just greedily put all these people into the prefix of the row, right? First, we put the lowest people in the first row, then put the second lowest into the row, and fill up all these spaces, right? So because we have only 30,000 of different heights of people, so that means the overall complexity is log n multiplied by c and multiplied by this guy, right? This is the complexity of the greedy algorithm to find out if a certain number of people in one row can satisfy the parade condition, right? So let's take a look at the code. So this is the iteration of the test cases. And we are going to read n and k, and we are going to read the number of people in a certain height, right? And we are going to do binary search here, and this is the initial left point. This is the initial right point, and we are going to iterate 250 times, right? That's usually the upper bound of log n, right? And for each iteration, binary search iteration here, we are going to find the middle point and test if the middle point can satisfy the parade's condition. So just check if we have enough number of rows in the parade, right? And if it can satisfy the condition, then we check the right part which means we are going to assign the middle point to the left point, right? And if it cannot satisfy the condition, then we are going to check the left part, right? And with the binary search being done, we can output the answer, right? So the answer of the binary search is the length of a row, and this k is the number of rows. So we multiply them together to get the total number of people in the parade, right? And I guess that's it. Hopefully that can help you to understand this problem. So have a great day. Thank you for watching.